Hi everyone, today we're going to look at factorizing binomial terms. So it is more or less one step up from the basic factorization we did last time. So things like if we have 2x squared plus 4x, we can recognize that the first term is 2x times x, the second term is 2x times 2, so we can actually factor the 2x out of both, so we end up with 2x times x plus 2. Okay, so today we're going to do one step up, but before we look at factorizing binomial terms, let's quickly revise binomial expansions, because binomial factorization is in fact the opposite, the reverse of expansions. Now, let's look at this basic example. Yeah, so we've done a few of these. Well, we've done actually quite a lot of these last time. So let's look at how it's done. What we're going to do is we can basically distribute the second term to the first two. Yeah. What we do is we distribute x plus 2 to x. So we have x times x plus 2 plus 3 times x plus 2. Because what we have done essentially is just treating whatever is here as a single entity, and we have distributed to both terms in the front. And then what we end up with is x squared plus 2x, because once again, distribution as per normal, we distribute x to the two terms in parentheses, and we distribute 3 to the two terms in the parentheses as well. So we distribute, and then we end up with plus 3x plus 6, because 3 times x is 3x, 3 times 2 is 6. So we end up with this term, and we gather the like terms, x squared plus 5x plus 6. And this is basically how we do expansion. Now what we need to do is the reverse. So in binomial expressions, when we're trying to factorize something like this, we have to go backwards. So we start from here, and then we go back, and then go back, and then end up with the two factors. So, okay, so by the way, these are two factors because we are multiplying these two entities together to get something. So we're basically turning this expression into its two constitutive, this expression here into its constitutive components. So the two factors, okay? So that's what we do. So the idea is, if we start up with an expression x squared plus 5x plus 6, we have to go down all the process, and then we separate everything, and then end up with x plus 3 times x plus 2. Okay? So that's what we're aiming to do. Now, in here, because we already know everything, so we kind of know that this 5x is composed of the 2x and 3x here. So we can just say x squared plus 2x plus 3x plus 6. And then we can separate further. Sorry, we can factorize this further. And then x, so the common factor here is x. So x plus 2 plus the common factor here is 3. So x plus 2 again. And then what we do is we factor these two out, and then that's what we end up with. Now, think about it. So the crux of the procedure here is to recognize what to separate the middle term into. So here, because we already done expansion, we know to separate it into 2x and 3x, and then factor it further. What if we do not know what it is? So for example, here, In this example, we don't actually know what is meant to be. So all we can do right now, is to write standing for them. So x squared plus ax plus, so we don't know what a and b are, and that's something we need to find out, plus 2. Okay, so here, this is what we end up, and our ultimate objective is, so we have here, so what our ultimate objective is to find something that will satisfy x plus a times x plus b, yeah? What we need to find is what a and b are respectively, so that when we expand this expression, we'll end up with this, yeah? So let's try it. So let's expand this very generic expression with no regards to what a and b are respectively. So let's say we have, let's just do it quickly, x plus a, x plus b. So if we expand it, we have x times x. So x times x, which gives us x squared, plus a times x will give us ax. X times b here will give us bx, and b times a here will give us plus ab. Should be a plus here. So if we add all of these up, we should have x squared plus ax plus bx plus ab. Now, let's compare the terms here. So for our expression, it's x squared plus 3x plus 2. Now, x squared plus 3x plus 2. So what can you see here? We can see that in the middle, we have ax plus bx has to equal to 3x. So what we need to do is we need to record that ax plus bx equals to 3x. Of course, that means a plus b has to be 3. And then secondly, a times b has to be 2. A times b has to be 2. Okay, now we need to find a and b, two numbers that satisfy these two conditions. Which two numbers, when you add them, you get 3, and when you multiply them, you get 2. Of course, there is only one such combination, which is 1 and 2, isn't it? Because 1 plus 2 gives you 3, 1 times 2 gives you 2. So we now know that A and the B have to be 1 and 2 respectively. So we can just go back to the original one and say, well, it has to be x squared plus 1x plus 2x plus 2. Oh, and it works because 1x plus 2x equals to 3. 1 times 2 equals to 2. And now we can factorize. We can factor x out of these two. So we have x times x plus 1 plus, and we can factor 2 out of this one. So 2 times x plus 1, because we're factoring 2 out of 2x and 2 out of 2 as well. And then, of course, next one we can factor x plus 1 out. So we have x plus 2 times x plus 1. Yeah, so that's what we have. And if you really want to verify it, we can check x plus 2, x, that's horrendous, x plus 1. So what have? X times x is x squared, 2 times x is 2x, x times 1 is x, 2 times 1 is 2, so we end up with x squared plus 2x plus x plus 2, so we end up with x squared plus 3x plus 2, which is exactly what we want. Okay, so same thing. Here, this one has some negatives, but will work exactly the same way. Okay, so just imagine once again what we're trying to expand. So here instead of x, we have v, but everything's the same. So let's say v. So in the end, we want some expression that looks like v plus a times v plus b. Yep, that's what we're aiming for. We want an expression that looks like this in the end. But you may say, oh, these are negative here. But doesn't really matter because a and b can be negative. So if we have a negative a and b's, then plus negative is the same subtraction. So we still can have the negatives here. Okay, so what do we do? Now, here, let's draw up the table again. So v plus a times v plus b, yep. So what do we have? V times v, of course, v squared. Here, plus av plus bv, and a times b is ab. Okay, so if we combine everything here, what we end up should be v squared plus av plus bv plus ab. Okay, so if we match everything here, v squared minus v minus 6, what we need is a plus b. So a v plus bv has to be negative v, and and a times b has to equal to negative 6. Okay, what does that mean? The implication here is that a plus b has to be negative 1. Because if it's negative, it's a negative 1 here. So if it helps, just to remind yourself that you have a negative 1. Okay, so a plus v. Why was this happening? Okay, so a plus b has to equal to negative 1, and a times b have to equal to negative 6. Now think about it, which true numbers satisfy these two conditions? So obviously there are two numbers that 6 have two obvious factors with a difference of 1. So if it's 2 and 3, yeah. So 2 and 3 are factors of 6. So a and b can be 2 and 3. But they have to be negative 6, which means one of these two numbers has to be negative. And because their sum is also negative, it means the larger one has to be negative. So it's negative 3, isn't it? Because negative 3 plus 2 is negative 1, and 2 times negative 3 is negative 6. So that's what we want. And then we can just substitute 2 and negative 3. So we have 2v and negative 3v in it. Now, if we go back to our original, then we can write it as v squared plus 2v minus 3v minus 6. Okay, so to factor things out, the common factor here in the first half, it's v, obviously. So v. What's remaining is v plus 2. And then the common factor between these two is negative 3. So we can subtract 3 out. What we end up is v. So negative divided by negative 3. So it's plus 2. And then we can factor these two out. And we end up with v minus 3 times v plus 2. And that's our answer. Yep. So have you noticed the pattern now? The pattern is if we can separate the middle term where the coefficients of the variable, so here is v. If we separate the middle term, then they have to add up to this number and they have to multiply to this number. Okay, so let's try with the next example. Okay, let's look at this one. So x squared minus 5x plus 4. Okay, so basically we want to separate it. So we want to have x squared something something x something something x plus 4, isn't it? So we want to find two numbers where these two numbers, where they add up equals to -5 and they multiply to +4. Okay, which two numbers satisfy these two conditions? I'll give a few seconds to think about it. Which two numbers add up to -5 and multiply to 4? Okay, so did you get it? So if you're still unsure, think about it. What are the factors of 4? So which numbers multiplied together would give you 4? So obviously it's 1 and 4 and 2 and 2. Of course, 2 and 2, they have nothing to do with 5. 1 and 4, when you multiply them, you do get 4. Yeah. However, when you add them, you have to get a -5. So they have to be negative, both negative, because negative times negative is positive. -1 times -4 gives you 4. -1 plus -4 gives you -5. So we can safely say it's -1 and -4. Okay, now we can factorize everything. So the common factor here will be x. So we can factor x out. X minus 1, and this one, the common factor obviously is -4, so -4. Because we are factoring -4 out of 4, so we're factoring negative out of a positive, so we end up with negative again, and we end up with x minus 4 times x minus 1, and so there is that.